Hello guys, today we will write a function which find the path in a binary tree to some node from the root to this node. So how we can do this? Okay, we can do this in terms of all paths function. We can take all the paths in the tree from the root to every leaf, all the paths. So, and we can filter the paths which contain our searching node in it. And when we can take one of them and then take all the elements from the root till the searching node in this path, and this will be our searching path. Okay, let's start to write this function. First of all, let's write all paths functions. It's very simple. I already do video about this, but let's write this. Okay, we have this binary tree which has this representation. It's polymorphic data type which contains some a, the binary tree, either the empty tree or the node which contains this a value and two binary trees. Okay, we recursively define it here, and let's define our function which return all the paths, and we start with type signature. It will take some battery of type A and produce a list of lists of type A. Okay, and we write some simple case, then the binary tree constructed with the empty constructor. In this case we just return the empty list because there is no paths in this tree. And if our tree is constructed with a node constructor which contains some a value and left and right subtrees, how can we define this function here? If we have a subpaths, okay, we can take the all subpaths from the left and right subtree. We can take them using this. We can call the paths function and paths L and paths R function. We will concatenate these two lists, and we will take all the paths which goes from the left subtree and the right subtree. But we have also a node, and we need to add this a node to every of these paths. So let's mark them as subpaths, and here we have some definition. Okay, if our S can be empty, okay, it can be empty list, and in this case we must return our a. The only path is the path which contain only one path is the path which contain a itself, and otherwise we need to fmap to our S partially applied cons with our A. Okay. If all subpaths empty, we return our one path with A, and otherwise we map this over list of all our subpaths. We add A to every subpath, and we define our subpaths here. Okay, I think this should work. Let's try to load this. Load BPHS. Some errors. Okay, of course I need to add some EQ instance for type A here. Okay, and now let's try to run our paths function with this tree. There, I already do tree here, and this is important. Let's assume that our tree contain unique elements. So let's assume what this is some ID for every node. It contains its ID, and there is no duplicates here. And let's run our paths function with tr. Yes, and we can see that I've got all the paths, all the possible paths from the root. And of course, using this, I can find, using these paths, I can find any path to some node of my tree. And first of all, let's define type signature of path function. This function will find the path to every to some node. Okay, we need some node A of type A. We need some battery which contains the nodes of type A, and we will produce a maybe type which contains a list of A. So the list represents the path to this node. Okay, and of course I think we need EQ here, EQ constraint to our type A. Oh. And let's define our function. It takes some A and some tree. Okay, first of all, we need to find all paths. As I said, we need to find all the paths, and I can do this using our paths function, and I will pass the T tree to it. Okay, then we have all these paths. We need to find paths which contain our A. How can we use this? Okay, we can use this using the filter function. We can just filter with some function our list of lists. And what function I need here? Of course, to search in a list we need an lm function, and we will use it here. Lm function, let's look at its type signature. You can see that it takes some A, some list, foldable list can be here, and produce a bool. So if we partly applied it to A, to our A, search A, we will get here a function from tier A to bool. Okay, and we can use exactly this function in the filter function. Let's look at its type signature. You can see that it takes a function from A to bool, and we have this function here and a list of A, and we pass the paths here. So, and it will filter to us only the paths which contain this node, searchable node. Okay, let's reload this. Some problems. Of course, there is a problem here because we need to return a maybe, and I returning just a list. Okay, and to fix this, we can use a very interesting function which defined in this data.maybe module, and it's called list to maybe. Let's look at its type signature. List to maybe. I need to define list to maybe. I do some errors. This is strange. I have problems. Okay, let's just use this function here, list to maybe. What it do? It's take this function. It's take some list, and this, if its list is empty, it return nothing. And if this list is not empty, it takes the first element from it and return just. So, why we taking only one element from it, the first element? Because we need only one path from our find paths. And let's try to reload. Yes, it loads, and I can see the type signature of this function. Okay, it take a list of A and produce a maybe A. And we satisfy this, all this expression satisfy to our final type signature. Okay, let's run our path function to find some node in our tree. For example, I want to find node F. I will pass it to our function and pass our tree. And we can see that actually it find me this path. But if I put, for example, something what not in the tree, it returns me nothing. But if I put C here, you can see that it's gives me the whole path to the leaf. But I don't want this. I want only path to my searchable node. And how can I do this? Of course, I can use this using the interesting function which called take while. So this means that we take nodes from our list till we find our element. Okay, but we have maybe here, just value, this type maybe, and we can't simply apply this function to it. We need to, okay, the maybe is a functor, and we need to use the map of our maybe using the map function. And let's just pass our take while function here, and they need to partially apply to some function, which this function will check for not equality to our a value. Okay, you can see if I partially apply to not equality our a value, it will take one value and produce a bool. Okay, and it can be used here. So I think that this expression should work. Let's just check this. I reload and try to find the path. Okay, we can see that it take me all the nodes before C and not C itself, because take while stops then defines C, and this means that they need to take all this final list and fmap list addition concatenate function partially applied with our list which contain a, only a, and if we do this we will receive our expected list, I think. So let's do this. Yes, you can see that I've got the path, only the path. Okay, let's check the root. Yes, and let's check if you find G, for example. Okay, if we find G, yes, it works. And if we find D, for example, yes, it works. A, B, D, A, B and D, yes. But if we find B, E and B, yes, it works as expected. So we write function which search for a path to a node from a root to any node, and of course if there is no such a node it returns nothing. So I will push this code in the gist, you can follow link in the description, and thanks for watching. Push subscribe button, push like button, write comments, and see you in the next video. Bye.